Good afternoon, sir. So this will be my recording. Um, so I will move on to the first question first. So this is my cover page, and also this is my the acknowledgement. So for case study one, the question A. First step, before I do the question, I actually rearrange the table so that all the 2018 data in one column, same as 2019 and 2020 data. So after that, I write down the factors and independent variable, which is shown here. I also write down the hypothesis, and also I I have created a two-factor ANOVA test with replication using the function using the data analysis function. Yeah. So uh why I use the two factor, because it is two factor, and also why I use the replication because in each factor there are more than one area. Like for major there have four areas, and for year they have 3 years. Yeah. So according to the ANOVA table, we can see that the F value is less than the F critical. So I for all the three hypotheses, yeah. And also the all the three p value is more than 0.05, so we will reject the we will not reject the null hypothesis, which means for the first hypothesis, factor A have no significant effect on dependent variable, and for second hypothesis, factor B has no significant effect on dependent variable, and for the third hypothesis, factor A and B interaction have no significant effect on dependent variable. Yeah, so this for the question A. And for question B, actually create a new table using the average number. Yeah. So this is the table, and so I have also created a line graph. Yeah. So according to the graph, we can see that there are a lot of intersection point, which means that uh, the graphs, which means that null hypothesis should not be rejected as yeah. This means that factor A and B has no interaction. Factor A and B interaction has no significant effect on the dependent variable. Yeah, so for part C, I actually rearrange the table bit to like this, so that all the occupation is at the first row, and also their relative uh, variables. Also, I write down the null hypothesis and the alternative hypothesis first. I create a single factor ANOVA table. So according to the table, we can see that the F value is bigger than F critical, and also the P value is less than 0.05. So this means that we need to reject the null hypothesis. So the final conclusion will be at least the conclusion will be at least one of the mean is not equal to the others. So since there will be at least one of the mean is not equal to the others, so I need to calculate which mean is that. Yeah. So like that, I will construct a confidence interval table. So in order to create this table, I need to know all the relative values. Uh, all the values can be calculated through this formula, which is shown here. So this is the result. Yeah, and this is the T confidence interval. And with this, I can calculate the lower limit and upper limit of each pair. So this formula will be this formula is where wait. So this is the formula to calculate the lower limit and upper limit. So after calculate that, after the table is created, I can see that only one pair is not equal, which is occupation B and E. And since the lower limit and upper limit value is all positive, so I can know that the occupation B has a higher mean than occupation E. So final conclusion will be uh, final conclusion will be wait where final conclusion will be the means factor wait no final conclusion will be in conclusion B and E is salary statistical means differ, so the B is big uh B has a higher mean than E. So yeah, this is question C. So now move on to the case study 2. For question A, which is quite simple. I will create a table like this. So the table I first only have you have list column and list column and the observed frequency. So in order to calculate the probability, I need to know the mean number, which is using this formula, which is using the formula, yeah, this one, to get the mean value. And then I once I have the mean value, I can calculate the probability using the formula, yeah, to get the probability. And for the last line, the probability, I use the 1 to minus the rest of it. So since the total probability will always be 1, yeah. So once I get the total probability, I can calculate the expected frequency with a total number of frequency calculated here. So I use a frequency, I use the total number of frequency times the probability to get the expected frequency, which is shown here. And with this, I calculate the test statistics. Yeah, the formula is shown here. Use this observed frequency to minus the expected frequency and to the power of 2 and divided by expected frequency. So this will be the test statistics. And for critical value, the formula is uh here. Yeah. So the 0.5 is use 1 to minus of the level of significance, which is 0.05. And for the value of 4, we actually use this formula, k minus probability minus 1, which is 6 minus 1 minus 1 minus equals 4. So the k is actually the number of applications. So here is 6, so the number of application, so the k is 6. Yeah. So the formula will get this value 9.488. So here will comes to the conclusion. Since the test statistics is bigger than critical value, we will reject the null hypothesis, and the means above model is not the above model is not appropriate. Yeah. So for question B, right, it's also the table is actually the observed frequency, but in order to calculate the expected frequency, I need to add one more row and column to calculate the total. Yeah. So here is updated observed frequency table, and we copy the table and paste on the other side, and delete all the values with highlighted in green, so that and then we use uh we use a formula we use this formula to get the first expected frequency value, which is here, and the rest will be calculated in the same way. Yeah, so with the observed frequency and expected frequency, we calculate the test statistics, which is shown in this table, and the same calculator way just mentioned previously in question A. Yeah, and or same as the critical value. So now comes to conclusion. Test statistics is bigger than critical value, so now hypothesis will be rejected, and gender and position are now independent of each other. So now come to the question C, part 1. So part 1 is quite simple as all as the dependent variable and independent variable is provided in question. So we have a format which is like this, but we don't. But just at that time, I don't have the coefficient, so I need to create a table using the regression function uh, inside the data analysis function. Yeah. So along with regression statistics, the another table and residual table also provided. This will be talked about in part three. Yeah. And with the coefficient provider, I can have this formula. So now is part two. So for part two, we calculate the correlation coefficient using the formula, using this formula. So one of the array is independent variable, the other one will be the dependent variable. So now according to the formula, can get all the three correlation coefficients. With shown here, which quite hard to see. Right? So one is 0.531, one is negative 0.843, and one is 0.749. So after that, the three graphs will be plotted according to this, and and we can see from the graph. And from the graph, we can see that for home size, it has a direct correlation, and it's moderately strong and positive. And for total monthly working hours, it has a inverse correlation as the length is moving down, and it has a strong and negative, and then it's strong and negative. Yeah, it's shown here. And also for number of family members, they are directly related, and there is a strong and positive relation between them. Yeah, which can be seen here. And for part three, this is a residential output uh, have created through the data analysis. And here is a residential plot. So from the plot, we can actually identify two outliers, which is shown here highlighted in yellow. Yeah, and also from the owner table, we can see that all these four p-values, all the p-value only have one p-value is less than 0.05. So this means that the model is statistically significant and it is a good model. Oh wait, no. So the independent variable are good predictors, and the independent variable is a good predictor for the p-value less than 0.05, and it is statistically significant. Yeah. So and so f values, the significance f is less than 0.05. So this means that the model is statistically significant and is a good model. And also from the regression statistics, we can know that the R square is 0.66763. So this means that about 76.3% variance in monthly power usage is dependent on number of family members and total monthly working hours and home size. Yeah, so that's all for my recording. Thanks.